Here we go. Hello, everyone, and thank you for attending Day 2 of the Optical Networking Digital Symposium. Thank you to our platinum sponsors, Fujitsu and Cisco, and our gold sponsors, Acacia and Adva. Before we begin, I want to cover a few housekeeping items. On the left-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit them to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget, as well as other resources made available for download from our sponsors. Towards the end of today's presentation, we'll ask you for your feedback. A survey will pop open on your screen, and it will only take a minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Heavy Readings Analyst at Large, Simon Stanley. Simon?
Hello and welcome to our second Optical Networking Symposium. I'm Simon Stanley, Analyst at Large at Heavy Reading. Just before we go on to our first session, I'd just like to take a few moments to outline the topics and speakers we have lined up for you today. Our first session is the Coherent 400 gigabits per second revolution. I'll be leading this session, and we'll be joined by Mike Filer, who is Principal Engineer, Optical System Architecture at Microsoft Azure. We also have Carl Gass from Carl Gass from the OIF, who is the Physical and Link Layer Working Group Optical Vice Chair. We also have Tom Williams, VP of Marketing at Acacia, and Rehan Zaki, who is Principal Architect, DCI Strategy and Planning at Fujitsu. Then at 12:30 Eastern, after a short break, we will go to the second session, Open and Disaggregated Optical Networks Reality Test. That will be led by my colleague Sterling Perrin, Principal Analyst at Heavy Reading. Sterling will be joined by Victor Lopez, Technology Expert at Telefonica, Ron Johnson, Senior Director of Architecture and Product Management for Cisco Systems Service Provider Transport, and Stefan Brettenberger, who is Senior VP Marketing and Investor Relations at Adva. So with that, we'll get started on the first of our sessions, the Coherent 400 gigabit per second revolution. In this session, Mark Filer from Microsoft Azure will be giving our keynote presentation, and then we'll go on to a short presentation given by Rehan Zaki from Fujitsu, our platinum sponsor. We'll finish this session with a panel discussion, including all of our speakers, and a Q&A session. So please send in any questions you have for our speakers as we go through. So now I'm very pleased to welcome our keynote speaker, Mark Filer, Principal Engineer, Optical System Architecture at Microsoft Azure. Over to you, Mark.
Thanks, everyone, for tuning in. As Simon mentioned, I'm a Principal Engineer in Microsoft Azure, working generally in Optical System Architecture. Previously, my focus was more on Metro DCI and long haul, and I've recently transitioned roles to be focusing more on some forward-looking technologies and solutions inside the data center. But I had a heavy hand in being involved in the 400 ZR and related developments through the industry and in consortia like the OIF, and so wanted to speak to that today. So let me see. Okay. This provides kind of a high-level global worldview of Microsoft Azure data center presences. And in order to provide high availability and high performance cloud computing services to our customers throughout the world, we need to have local compute and storage presences close to those customers as is economically feasible. Which generally means, having a widely distributed networks like we show here. Today, and these numbers may not be spot on now, but I try to keep them as current as possible. But Microsoft Azure has 53 live regions, another 5 which have been announced. And it's also important to note that interconnecting all of these regions is over 161,000 kilometers of fiber and subsea cable. So it's not a small network by any means, and it's useful to have that backdrop as context in the discussions that follow. So I wanted to first kind of take us on a path of how we got to where we are in terms of how we build out each one of these regions. And that gives good context for how then we'll use 400 gig coherent in this next wave of technology that's coming online soon. So Microsoft, like a lot of the other big cloud providers, initially started out with this kind of mega data center concept. So we would build these large singular facilities on a single campus within kind of a 2-kilometer max distance between any 2 physical data center facility on that campus. And these were kind of grouped logically into 4s. You see 4 data centers there. And the data centers would be connected to what we called our CNRs. I think that's core network room, via bulk fiber, just massive parallel spans of bulk fiber and gray optical cables. And to give you kind of a visual of what one of these mega data center facilities look like, this is an aerial view of one of our facilities. I believe this one's out in Quincy, Washington. And just to give you a sense of scale, each one of these white buildings here corresponds to this data center block down here. 2 Boeing 737s could fit nose to nose in each one of these. So that gives you somewhat of a sense of how large these facilities can be. And so the core network rooms then were what tied our local regional data centers into the rest of the Microsoft network, interconnecting the regions together via our own private long-haul network, and also connecting to our edge and peering locations to get out to the capital I internet. So before I move on to this one, I'll just also add that this design generally served our needs at the time and enabled us to meet the capacities that we needed as we could project growth. But there were some, I would call them shortcomings or drawbacks, which maybe weren't fully appreciated at the inception of the design here for this type of approach. One was that the construction times consistently tended to be prolonged, and meeting timelines were, it was just always under a lot of time pressure to get these facilities online as quickly as we felt like we needed them to keep our customers running well. And the day one cost to build one of these large monolithic facilities didn't always justify the capacity needs for that region. Secondly, scaling the capacity in a region was complex. Once you exhausted the capacity of one of these local facilities, you basically had to build an entirely new one somewhere else in the region. And so again, pointing back to the cost and timeline overruns, that became problematic. And lastly, these large campus facilities like this aren't fully resilient to catastrophic campus level failures. You think of a localized tornado or something that hits a data center and takes the entire region offline. So that kind of gave rise to this notion of regionalizing our campuses. So taking the same core building blocks, if I switched back to the previous view, it's the 4 data centers and the 2 network rooms. We basically retained that same idea, and we renamed the core network rooms Regional Network Gateways, that's RNG, and distributed these over a wider metropolitan area, and tied each data center back to the RNGs redundantly via DWDM fiber. That was the idea. And the maximum distance between any 2 data centers is actually bounded by a maximum latency spec that we impose It's around just under 2 milliseconds. And this latency number is driven by the end user requirements of their applications. The application needs to feel like if you have storage being served up out of one data center and compute out of another, that it still presents to the user with no special considerations in their applications as one mega data center type of structure. And imposing that distance requirement or restriction helps ensure this. So another advantage of this approach is to scale the region is simply a matter of procuring additional data center facilities, which again are much smaller than the large campuses that were shown on the previous slides, and tying those back via dark fiber redundantly to the RNG. And I should also note that dark fiber within these metro areas is typically much more readily available and easy to procure than, say, long-haul dark fiber, where you might have a few fiber pairs available for a nationwide backbone. Typically, tens of fiber pairs are available between each data center and RNG at low cost. And then lastly, another benefit of going to this regional model is the notion of availability zones, which I have labeled here AZ set 1 and AZ set 2. And this is just providing this geographical resiliency that was lacking from kind of the mega data center approach, where even if a tornado strikes, AZ set 2, your region is still online and the capacity is being presented by AZ set 1. So I wanted to dive in a little bit between or looking inside what's in those building blocks I was showing in the previous slide. At the top, I'm showing the 2 RNGs, and toward the bottom, I'm just showing a single data center for simplicity, but just showing kind of what the ecosystem is and how it is constructed, which again, I think is instructive to understand how we interconnect our DCI networks and where 400 gig coherent will play a role. So down all the way at the bottom of the network, you see individual racks, servers connected to what is commonly called a top-of-rack switch. And those distances are limited to about 2 meters, and it's done via direct attached copper, which is just copper cabling, essentially no active optical components involved. And then at the top of the rack, we connect into a band that we call Tier 1. You also hear them commonly called, I guess, let me think, leaf routers or switches. And these distances are limited to about 20 meters. It's done via AOC cables, and it's connected up in the cross fabric as shown. And then each one of those, which we call a row, or equivalently you could call it a cluster, those tie into our Tier 2, or what might be called a spine and other providers. But those connections are still bounded in distance within the data center facility. We cap it at 600 meters. And we actually have parallel fiber plant installed in all of our data centers globally, with an eye toward the future, knowing that you'll have to move toward more massive parallelization to hit the capacities on these links that we need to. And I think this is the more relevant part for this talk, we then interconnect our data centers to RNGs via DWDM links, again, redundantly to each of the 2 RNGs from each data center, but also geographical redundance with logical west and logical east that correspond to physical west and east paths. So we have a lot of redundancy built in. And as I mentioned, tens of fiber pairs on each one of these paths between data centers and RNGs. And then lastly, any traffic that needs to leave the region, bound for other regions or the internet, leaves via our optical core routers over our long haul network. So what I want to do is zoom in on one of these links and look exactly what we're doing here, because I think this is a little bit subtle and distinctive from maybe other DCI applications. Or when I say DCI, I'm referring to these links here between data centers and RNGs. Anytime I say that in this presentation, that's what I'm referring to. So let's zoom in. This is the same link. I'm just drawing it in a different way and expanding it out to show exactly what's there. We were extracting hub routers and tier 2 routers into a single box in the previous image, but what you actually have physically, depending on the data center and region size, is up to eight of these hub routers and 4 of these tier 2 routers sitting in the data center. And we are logically connecting these in a closed fabric. So you have each router striped across all of the other routers at the far end. And these are 100 gig links. And, you know, the way we're doing this, as I mentioned before, we're doing this over WDM. So each one of these is a different color, and they're piped over a common line system and a common fiber pair over distances of 100 kilometers. But, you know, I think understanding this, that this is what Microsoft doing is actually connecting the spine layer to, you know, what is commonly called a super spine layer or something like that via a full cloth, you know, mesh fabric like this. It really helps to inform, you know, how we use this product, and helps folks to understand, I think, as well, how this drives kind of massive capacity in this DCI space. So, you know, kind of stepping back, looking back in the 2014, 2015 timeframe, the only way that you could have achieved connectivity like this over these types of distances would have been to take an approach similar to what's shown here. So I'm showing at the left side of the slide kind of the data center, the switches that are inside the data center, the tier 1 and tier 2 interconnected. And those would have been piped via gray optics into DWDM transponders. We call them pizza box transponders commonly, because they are these kind of cloud operator optimized form factors. And those are aggregated, sent over a line system, and the same thing happens at the far end RNG. The line system and the transponders would have been proprietary, meaning from one vendor, and kind of a closed ecosystem with proprietary NMS for control and monitoring. And the main issue with this approach is that it's prohibitively expensive, space and power hungry for the scale and capacities that we needed to run to enable our regional architecture, to fully build out that cloth fabric like I was showing on the previous slide. So, you know, kind of around 2014, we had this idea, okay, we need to collapse these DWDM signals into this small switch pluggable form factor to overcome this problem. How can we do that? Well, we engaged multiple suppliers just through our own internal Microsoft connections about building something like this. And no one had anything like this on their roadmap until maybe 2017, 2018 timeframes. But one partner kind of stepped up and said, well, we think we can build something like this. And this was decently well publicized at the time. It was Inphi. The product ended up being the Colors, Inphi Colors DWDM PAM4. And what it is a QSFP pluggable 100 gig PAM4 module that's designed to be just good enough, you know, in terms of performance to close these types of 100-kilometer distances. You know, a key shift here is that we're getting rid of all of the pizza box infrastructure, all that space and power, and the connectivity that's required to connect and manage that. We're running open line systems now to be able to handle these, you know, what you can think of IP over DWDM or alien wavelengths over these metro distances. And it just led to massive cost, space, and power reduction. You know, the transceivers are 4.5 watts per 100 gig. And this was the key enabler for running the types of capacities and scales that we needed to really build the regional fabric with the resiliency and capacities that we required. So, you know, just to give a sense of scale, again, stepping back and looking at our regional diagram, when leveraging this type of solution, you look at the cross-sectional bandwidth across a region in that DWDM portion. We're running today in our larger regions over 1.6 petabits per second of capacity to interconnect these data centers and RNGs. And then likewise, the impact of shifting our designs to this regional approach and running the DWDM through the metro like that has really caused a huge uptick in the number or amount of deployed DWDM in Microsoft Network. So you can look, we started initially deploying this Colors product in late 2016, early 2017. And the ramp has continued consistently. I wish I had data for 2020. I didn't have time to track it down. But, we're talking, tens of thousands of ports year over year increase in the total DWDM footprint in the Microsoft network. Likewise, I guess shifting gears a little bit, as we've deployed these systems and built out regional presence throughout the world, we've also been gathering statistics on what exactly that infrastructure looks like. And these two charts here, the one on the left is showing a histogram of metro fiber distances. The one on the right is a histogram of losses for those same fibers. And, this is, I can't remember, over 4,000, I think, fiber pairs worth of statistics, maybe more. But the big takeaway here is that looking globally across all of our deployments, the distances and losses that we are closing these systems over are well bounded and well defined. Our distances practically, I showed 100 kilometers on my previous slides, but practically the distances are 70 kilometers or less, the vast majority under 60 kilometers. And likewise, the losses don't generally exceed 15 or 16 dB. Some of our worst case fiber spans may be up to 20. But I show this data to highlight again that the problem space here is well bounded, and we're just needing some solution, in terms of an optical transceiver that's just good enough to close these types of links. We don't need overkill like the pizza box transponder type solutions were, and one size fits all Swiss Army knife type of pluggable. We just need something that's focused to solve this problem. So I'm going back again to the slide we looked at previously for how we did this in the 100 gig era, and looking forward now to how this will be solved in 400 gig. So as you see between the two slides, not much change. The data rates of the routers went from a 100 gig MAC to 400 gig. And then on the line side, nothing has changed topologically or physically in terms of how we connect things. But what you did see was a shift from a 4-level amplitude modulated signal to a 16-point constellation, with the implication being that, acknowledging that we'll be moving to 400 gig to Coherent to achieve 400 gig. So in kind of outlining, back in 2016 or so, when we were thinking about, okay, how are we going to solve this at 400 gig? We knew it would be most likely Coherent. We knew it would need to close 100 kilometers, just like the current 100 gig solution. And critically, we knew it still needed to fit into a 400 gig switch pluggable form factor like QSFP-DD or OSFP. Additionally, we knew that we needed to decrease the power per bit over the 100 gig generation, targeting about 15 watts. And I left an important bullet off here that I wish I included, and it's probably the biggest bullet, is we knew it needed to be interoperable. Because, while we had an identified industry partner for a 100 gig ecosystem, we were supply chain constrained should anything go wrong. And fortunately, nothing has, and it's been a very good program. But going forward, we knew it absolutely needed to be interoperable and multi-vendor ecosystem at 400 gig. Likewise, we knew that the line system could be further simplified because the sources would be coherent as opposed to direct detect, where you have to manage dispersion and things like that a little more closely. So, I just put the OIF eye candy here. I'm not going to go into the details of what 400ZR product is, because I think Carl and Rehan and Tom will cover the technical details of that pretty well. But just to say that, we, as I mentioned, we knew it needed to be interoperable at Microsoft. And so we, along with some other peers and suppliers, took this project to the OIF to get standardized in order to develop that interoperable ecosystem, and worked pretty diligently through the starting at the end of 2016 until actually this past February, the implementation agreement was finally voted from draft to being a formal IA, and you know, it was the hard work of a lot of folks, Microsoft and Google on the service provider side, among others, and then all the suppliers that were involved. This project had tremendous amount of industry backing, and was a pretty big deal, I would say, in the OIF. So Carl will speak to it in a little more detail later. But just to look forward to 400 gig, how will it be rolled out? How will this data center ecosystem change? You know, again, topologically, nothing is changing. The only thing that's changing is we're scaling all of our pipes up from 100 gig pipes to 400 gig pipes. And specifically, the 400 ZR product will fill in the roles that were shown previously for the 100 gig PAM4. It's interesting to note that the 400 ZR product is actually our gateway into the 400 gig ecosystem for switches and routers in general, because we take this tiered approach and kind of have disaggregated data centers and RNGs. We are able to upgrade each of the tiers of the network, or each of the bands of the network, I would say, in phases. So, you know, for greenfield deployments, brand new data center builds, they'll all be built 400 gig day one. But for brownfield or you know, refreshes of existing regions, this 400 gig ZR tier between these tier 2 and hub routers will be upgraded first. And because we use modular switches with line cards, we can upgrade each of the tiers, and in a cluster by cluster. We can upgrade from 100 gig to 400 gig on a cluster by cluster basis, and do kind of that impedance matching of the data rates at this tier 2 router. So really, you know, 400 ZR is kind of a critical enabler for this next generation and scaling our capacity in the Microsoft network. And that's all I had. And so I guess we'll have Q&A later, but now I'll be turning it over to Rehan at Fujitsu to talk to you about it from a service provider perspective. Thanks.
Hello, everyone. My name is Rehan Zaki, and I will be covering 400 gig coherent pluggable from a Fujitsu standpoint. I think what you'll see as a theme in the next few slides is that you know, it's very consistent with the approach that Microsoft is taking, but we're going to give a view beyond just 400 ZR. Obviously, it's a very exciting time in the industry where coherent technology is being standardized, and I think that's good for the broader ecosystem and for the service provider as well as the data center community as a whole. There are a few different data center trends that are driving the requirements for things like 400 ZR, OpenZR Plus, and even Open ROADM if we're trying to be comprehensive. The three main things that I will talk about are distributed architectures, purpose-built solutions, and what we're calling the next wave. Some would argue that wave is already here. But if we go back and we look at the distributed architectures, as Mark had correctly described the evolution of the data center, where we had huge, large, monolithic data centers serving you know, end customers, enterprises alike, that architecture essentially has changed over the last few years, and that's being driven by the east-west traffic growth. The east-west traffic growth is really, you have three types of traffic, right? You have one from the user to the data center, you have traffic between the data centers, and then you have traffic within the data centers. The massive growth in the east-west traffic, it's a huge order over the data center to user traffic, has really caused data center operators to change this architecture to a more distributed approach. I think the approach of multi-tiered data center is well known in the industry, but what has changed over the last several years is these data centers have proliferated in terms of campus-oriented data centers where there's not just one building, there's multiple buildings, and then within a particular region, these zones that are consistent of multiple buildings are interconnected by low latency, high capacity links. And these links are what are really driving the proliferation of coherent optics into smaller form factors. Today, these are being served by compact form factor transponders. The transition will happen to more efficient 400ZR, OpenZR+, pluggable optics within the router and switch environments in the data centers. If we look at what purpose-built solutions has done to the data center space, we started off with large chassis-based systems where we're plugging in line cards for transponder functionality, line system functionality, amplifier functionality. That transitioned over the last 3 to 5 years to more compact form factor, or what Mark referred to as pizza boxes, very custom made for the cloud space, making sure that the space, power, and density requirements are there. That transition will happen to 400ZR in the very near future, given that essentially what 400ZR and the OpenZR Plus standard will bring to the marketplace is a transponder and a pluggable, right? And these will be hosted inside a router or a switch at the data center. This effectively drives a lot of cost efficiencies, right, from three main perspectives. One is you're managing less electronics by eliminating a transponder between the router and the far end router of a data center. You're also eliminating back-to-back optics that would traditionally go between a transponder and a routing platform. And then the third is the cost of these pluggable optics going inside a platform of whether routing or switching vendors. Given that these will be standardized, we're expecting costs to dramatically decrease over the next several quarters. And then last but not least, what's happening in the marketplace are these solutions are becoming more and more open, right? So, managing these solutions becoming easier from a northbound and southbound interface perspective, as we all agree on things like netconf yang to manage comprehensively these devices. The next wave, as we're calling it, is the 400 gig revolution. 400 gig E obviously is already here, but we're expecting a phased transition from 100 gig E optimized platforms to 400 gig E platforms. And we expect a large portion of this to happen over the next several years with commercial deployments happening this year, but it'll be a phased approach. We still see 100 gig E as the dominant interface for the next several years, but I think in the next 3-4 years, we'll see that transition over to 400 gig E. So intra data center, we'll see 100 gig E links over time migrate to 400 gig E, and then inter-DC between data centers, these links of 100 gig, 200 gig coherent technology will transition to 400 ZR or ZR Plus platforms. So why coherent pluggables? This is really generalized for ZR optics in general. There will be several variants of optics available. I believe Simon will walk us through those. But the number one thing is network simplification. You're reducing the number of electronics in the network, reducing the number of managed entities in the network, and we're really standardizing on pluggable optics that are optimized for 400 gig optimized routing platforms. Reduced OpEx and CapEx. Again, just eliminating electronics from the network and driving volumes off pluggable optics that the industry has standardized on will greatly reduce costs for the data center environment. And then last but not least, industry standards. I mean, this is a very exciting time in the marketplace where we've agreed on standards for coherent technology with 400ZR, OpenZR+, and even OpenROADM. So we've outlined a few use cases here that we see speaking to our broad base of customers, and this is across the board of data center operators, service providers, and inter-exchanges. The very first application here is a router-based 400ZR application. This is pretty much what Mark had outlined in terms of connecting data centers with high-capacity pluggable ZR-based options. I think Microsoft has very well shown us how this model is a proven model over the last several years by taking PAM4 optics and plugging those into their routing and switching vendors within their data centers. I think the next phase of this is to enable 400ZR in the next generation 400 gig platforms. We will anticipate some retrofitting of ZR optics in 100 gig optimized routing platforms where they can handle the thermal and power requirements. But mostly we expect 400ZR to be deployed in 400 gig optimized platforms, the next generation platforms that are being introduced to the market right now. And then from a client perspective, we see just a host of 10 gig, 100 gig, 40 gig, 400 gig, various multi-service options available within the routing and switching platforms in the data center. The next application we see is a transponder-based application. As I said before, we expect this to be more of a phased approach in the industry. And what I mean by that is 100 gig interfaces will still be dominant in the marketplace over the next several years. I think that crossover mark is predicted by analysts to be the next 3 to 4 years when 400 gig from an interface perspective will take over 100 gig interfaces. So there's still a gap and a solution to be had for data center interconnectivity between routers and switches that still have 100 gig interfaces and that are optimized for 100 gig interfaces. And there's also a driver from an economic standpoint. If we look at where 400 gig client optics prices are today versus 100 gig, it's not where they can be so widely deployed, but that's coming. It'll happen over the next few quarters. So OpenZR+, which is think of it as the next standard beyond 400ZR, relaxed specs in terms of reach as well as multi-service client capabilities. So we're anticipating data center operators and service providers leveraging this technology with OpenZR+ to transport the existing 100 gig client infrastructure across their network. And the third application is a hybrid OpenZR application where we're still anticipating ZR pluggables inside data center routers and switches, but there is a handoff or a meet-me point at the far end that will be served maybe by an inter-exchange carrier where they will hand off that OpenZR+ interface to a transponder and then drop out or fan out the 100 gigs on the far end. So again, this could be an inter-exchange or interconnect application, or even potentially at cable landing stations where they're trying to drop out multiple lower rate client signals. So these are the three main applications that we see that will leverage 400ZR and OpenZR+ technologies. As I said before, from an industry perspective, this is a very exciting time in the marketplace. The 400ZR and OpenZR+ standards will enable new and open solutions, right? Again, this is really the first time that the industry is settling on these standards. And the demand that we're seeing from the marketplace is that there will be a requirement continually for both open as well as proprietary options. So we're going to see solutions come to the marketplace where a hybrid application will be required. A line system, for example, serving both coherent pluggable technology, as well as discrete optics technology. And so Fujitsu will be introducing a solution to the market that will essentially provide a solution for both pluggable-based coherent optics in the form of 400ZR, OpenZR+, as well as Open ROADM, as well as discrete optics where the performance is required beyond the reach of 400ZR and OpenZR+. There are some nuances associated with 400ZR and OpenZR+ technology in terms of the output power of these optics that still have to be designed for and alleviated for in the network in terms of amplification. And with this particular solution, we actually solve that. So it's a solution that brings to market multi-service client interfaces, but then the flexibility to support interoperable solutions both at 400ZR and OpenZR+. And then last but not least, from an open perspective, we're talking about leveraging DSP components in here that are generally available in the market, as well as interoperable, but also an interface that provides an open approach, meaning we can control these with standards-based netconf-yang interfaces. We give access to REST APIs to really make this solution an open solution that caters towards those operators and data center providers that are looking to, integrate this into their own back office and management and control platforms. That's all that I had. Simon, back to you.
Okay, thank you, Rehan. And that brings us to our first panel session. And for this panel session, I'm joined by our two main speakers, Mark from Microsoft Azure and Rehan from Fujitsu Network Communications, who you've already heard from. And I'm also joined by Tom Williams, VP of Marketing at Acacia, Carl Gass, who's Optical Vice Chair, Physical Link Layer Working Group at the OIF. So welcome to those two as well. During this session, we're going to be discussing several key topics that are particularly important at this critical time in the rollout of 400G coherent solutions. These include the impacts on transport costs for mass 400G over DWDM adoption, optical interoperability and open ecosystems at 400G, OIF 400G standardization, the rollout of 400ZR, and the value and development of ZR Plus solutions. At the end of the discussion, there will be a Q&A session, so please send in any questions you have for our speakers. Now, in the 10 years since 100G coherent solutions became available, we've seen a massive increase in capacity and a shift from line card and fixed module solutions towards pluggable modules. The first 100G solutions became available in 2010, and the OIF long-haul DWDM module agreement was completed that same year. Using 100G coherent and DWDM across the 4 terahertz C-band with 80 channels and 50 gigahertz spacing, capacity of a single fiber increased to 8 terabits per second, and the first pluggable CFP 100G Metro module was introduced in 2014. The first 200G solutions were rolled out during 2013 and 14, and as second and third generation DSPs became available, the form factor was reduced to include pluggable CFP2 DCOs and as well as ACOs, and that was around about 2016. Now, the first 400G coherent modules were introduced in 2015, supporting flexible rates from 100G to 400G. And really, 2020 is going to be a significant year for 400G coherent, as we'll see CFP2 DCO modules for 400G going into production, but also OSFP and QSFP DD modules for the 400ZR and ZR Plus solutions. And that's really going to be the focus for this session. Just to complete the picture, the first 600G coherent dual channel modules became available in 2017. And using 600G coherent and DWDM across the 4.8 terahertz extended C-band, so that's using 64 channels at 75 gigahertz spacing. Capacity is increased to around about 38 terabits per second, or you can double that to 76 using the C and L bands. At the end of last year and into this year, we also saw the first 800 gig coherent solutions, and these are primarily for data center interconnect. And we discussed 800G and increasing fiber capacity in our previous optical symposium on Tuesday this week. So if you missed that, then a playback is available on the LightReading website. Now I want to come to our panel, and I'm going to start with Tom and Carl Noss. What are the key technology developments enabling mass deployment of 400 gig over DWDM? So first, Tom.
Sure, thanks, Simon. I think there's actually a few things. I think if you look back over the history of Coherent over the last 10 years, there's been significant decreases in size, power, and cost per bit. So it's a trend that has been moving Coherent into being able to support these smaller and smaller form factors, just like you just reviewed. At the same time, you have advances in CMOS, so Moore's Law, we're going to smaller and smaller CMOS dimensions. So that allows us to bring the power down of the DSP processing. And then also, I would say advances in silicon photonics. If you go back a few years when we first started using silicon photonics, it was, we were kind of unique and it was viewed as sort of being high risk for these kind of applications. But now you see a lot of different companies that are really advancing the silicon photonics approach, which enables these smaller, compact, low-cost solutions. So I think it's the intersection of all of those things happening at the same time that allow us to get to these form factors that coincide with the client modules.
Okay, great. And Carl?
I really have to agree with Tom on most of that. I mean, I won't focus as much on silicon photonics, and instead I'll toot the OIF's horn. One of our projects was the IC TROSA, or Integrated Coherent Transmit Receive Optical Subassembly. And that allowed versions of both silicon photonics and indium phosphide. But the goal was that higher level of integration of the functions necessary for coherent transmission into a form factor that would fit these high density modules. So, that combination of advances in or advantages of smaller feature size in DSPs, lowering power, plus then bringing that coherent functionality into a very small package enabled 400 gig coherent functions in these small modules.
Okay, great. And then going on now to our second question, I'm going to go to Rehan. What do you see as being the biggest gains from 400G, specifically in the sort of long-haul metro and edge DCI market areas?
I think we'll see the biggest gains in the DCI space, given that the primary driver for these standards, 400ZR and OpenZR Plus, really focused on that environment. So if we look at the biggest gains, it'll be from a network simplification perspective, less electronics, as Mark so eloquently portrayed, as well as from a CapEx and an OpEx perspective, given that these technologies will be standardized. I think from a metro perspective, the biggest gain will be that operators will now have interoperable solutions, which essentially will provide much more flexibility and avoid vendor lock-in from their perspective now that we've got agreed upon standards for coherent technology. I think similar gains will be had from a long-haul perspective, although I think there'll be some contention there with high-performance proprietary modes from various vendors as well.
Okay, great. Going on now to next generation pluggable coherent modules. This chart's actually from Acacia and shows the OAF 400ZR solution for HDCI, and also solutions being developed by the OpenRoad MSA and the OpenZR Plus MSA. Now, the OpenZR Plus MSA was actually announced last week, so I'd like to just ask Tom from Acacia to say a few words about this development and how it fits in with 400ZR and the OpenRoad MSA.
Yeah, and there's been kind of an evolution in the industry. If you go back, Mark talked about the start of the 400ZR project in OIF, and what was being done there was really kind of groundbreaking and important work. And when we started that, we started with a very narrow scope, and I think that allowed that OIF discussion to progress and get to move forward and accelerate at a good pace. Then, as the industry attention to that was really getting focused, other use cases, other applications, and network operators started looking to say, how can I leverage that? So you had things like OpenROADM, who wanted to leverage that investment in that OIF was driving, but have a higher performance solution. And so they defined something that was higher performing and more focused on OTN type applications. I think a lot of component providers are trying to address these solutions in the same with the same hardware, and so that led to kind of a natural combination of the two, where OpenZR Plus kind of takes some of the higher performance features of OpenROADM, but puts it into the model. Again, if you go back to the original scope of 400ZR, we thought we were limited to form factors that could only handle about 15 watts, and over time, a lot of really good work has been done to allow higher power for those modules. And so, you can take some of the higher performance features and put them into these small form factors. So you're targeting the application space of 400ZR with some additional features and performance. And then also, like Rayhan was mentioning, the carrier applications might be more interested in, might not be so focused on the form factor, and might be more interested in addressing some of the output power constraints and things like that. So it's really taking all of these tools and making the right combination. So we view the market as being divided into these three solutions. All of them provide interoperability, but they're really 400ZR is kind of edge and metro DCI. OpenROADM's kind of carrier, mesh type applications, and then OpenZR Plus is Ethernet, but longer reaches, kind of regional long haul type reaches, and more functionality.
Okay, great. So coming on now to optical interoperability and open ecosystems at 400 gig. Going first to Mark and Rayhan. So how important is optical interoperability at 400 gig in your opinion?
Yeah, I'll go first. I think I touched on it a little bit in my my presentation, but yeah, at a high level, we viewed interoperability as critical, and that's why early on we decided to take it to the OIF to standardize. Like I was saying earlier, with the 100 gig ecosystem with the Inphi product, we essentially created a space that later became termed DCI that didn't really exist before, in terms of people acknowledging, oh, this is actually a decently high volume application that maybe multiple suppliers should get on board to develop towards. So, kind of once that was established, I think it was pretty straightforward to get industry support and standardize something equivalent for the 400 gig generation, this time at OIF. And so, having the interoperable ecosystem, I think will allow other providers, hyperscale or not, allow them to adopt similar solutions and maybe architectures without sweating the potential supply chain challenges that would come with a high risk or a single vendor solution.
Okay, and Rayhan?
I would agree. I think it's extremely critical in this environment where, that we see the growth in the DCI space, that interoperability happen at 400 gig. If we look back at history a little bit, we look at 40 gig coherent technology and look at 100 gig coherent technology, there was not much interop there. There was no standardization there. I think that resulted in high costs, vendor lock-in, and less flexibility in the networking environment. And I think this optical interoperability that 400 gig ZR and OpenZR Plus will bring substantial cost reductions, economies of scale, and flexibility in networking infrastructure.
Okay, great. Well, we're now going to go on to the next question. So given the importance of interoperability, And I'm actually just going to go to Tom because we are going to run a little short of time, and I want to make sure we get on to the audience questions. So I'm going to go to Tom. Is there still a place for proprietary 400G solutions, and if so, where?
Yeah, I definitely think there is. There, applications where performance, kind of trumps the interoperability. So in submarine type applications and long haul terrestrial, I think you'll still see proprietary solutions deployed, and there'll be an intersection point in, call it regional, where you might see some network operators who go with an interoperable solution and other network operators who prefer the proprietary. So I think there'll be a place for both.
Okay, great. Well, I'm actually going to skip the last question because I think Carl's going to talk a little bit to this. So what I wanted to do was ask Carl if he'd given a quick overview from the OIF perspective on the 400ZR developments.
Thank you very much. So quickly, OIF is an industry forum consisting of over 100 industry-leading network operators, system vendors, component vendors, and test equipment vendors. And for over 20 years, the OIF has developed, validated, and published implementation agreements for optical, electrical, and control technologies critical to accelerating market adoption of optical networking technologies. Sorry, I had to read that to get it perfect. Again, you've heard several things from Mark and others about 400ZR. The idea behind this project, we are a member-driven group. We had Microsoft and others line up to say this is a need. It's not being met currently anywhere else in the standards body group. We leveraged as many other standards bodies as possible, but kept a very focused effort towards a point solution. Clearly, there's a lot of variation possible, but our goal was to provide this form factor agnostic, but targeting certain form factors in order for initial implementations. Some of the additional things necessary were very form factor oriented. In particular, the Coherent CMIS. Existing CMIS for those form factors did not include either Coherent or DWDM functionality. So that was, additional efforts that went towards fleshing out the ecosystem for 400 gig Coherent deployment. One last thing. I will point out the standards bodies are meant to provide a single solution, but really we need to leave opportunity for vendor technical differentiation in the marketplace. Specifically, we feel we've provided an ecosystem, starting with DSP, IC TROSA, and this Coherent CMIS and line protocol that then can be leveraged for both improvements on the standard application as well as new applications. And I think that's what you see the other speakers primarily discussing.
Okay, great. Thanks, Carl. So just going on now to talk a little bit about 400ZR. Mark and Rehan, so what do you see as, the key attributes of 400ZR?
Yeah, I think top of mind is line side interop. That's the big one that is kind of paradigm shifting there. Additionally, I think as others have mentioned, photonic integration, the advances in silicon photonics and indium phosphide process to and the IC TROSA development to get the power and space envelopes down to something usable for someone like a hyperscaler is key. And then lastly, another enabler is the advent of open line systems and featuring standard data models and APIs and, basically the SDN, and I'm doing air quotes, SDN paradigm, I think has are all playing a big role here.
Rayhan?
I think from my perspective, there's two key attributes. One is that this is a pluggable form factor, and the second is that, as Mark said, it will be interoperable based on a particular standard. I think if we look at where we've leveraged technology before for data center interconnect, it's been retrofitting. We've been retrofitting high performance, long haul technology for data center interconnect. We now have a focused solution which again, I think will bring down significantly the cost in connecting data centers in particular.
Okay, great. Now going on to the next question. So this one's for Mark. How widely do you expect 400ZR to be deployed, and in what applications? I guess beyond the one you were talking about, if any.
Yeah, so, and the question was 400ZR specifically, right? Yeah. So, yeah. Widely, throughout the Microsoft ecosystem for sure, it will be both, powering the data center interconnect in new regional builds, but also going back and retrofitting previous generations that were 100 gig to 400 gig. So it'll be, massive deployment on the Microsoft side, and that deployment should start in earnest early next year. And, I think the application space is very well delineated for Microsoft, kind of highlighted by that slide I showed on the fiber distances and losses, DCI, sub 100 kilometers, sub 24 dB. That should cover anything and everything that we would need to use it for.
Okay, and I think that probably brings in this last question for Tom. How quickly do you expect 400ZR mass deployment to happen?
So I think some of the early adopters are expecting to start ramping in the first half of 2021. And then I think over the course of 2021, you'll start to see, more network operators start to come on board. So it will be a ramp. These things always take some time as operators layer on top of each other. But I think the earliest ones will start ramping in the first half of 2021.
Okay, great. Right, well, now going on to ZR+, and this is the last of our question lists. Rayhan and Carl, how important do you see ZR+?
Sorry, I was speaking on mute there. ZR+ is extremely critical. I think 400ZR serves a particular segment of the data center interconnect market, but ZR+ enables much more flexibility from a client-side perspective, and with the relaxed specs provides greater reaches and distances that I think can be well adopted in the metro segment of the network.
Okay, and Carl?
Completely agree. That was part of my last statement. Again, the standard provides a standard. And then, again, people building to that standard will demonstrate their technical differentiation by extending that to different application spaces.
Okay, next going on to the second question. To put Tom and Rayhan, where will ZR+ be used and at what reach?
So I think where it will be used is more complex than just reach. I think from a reach perspective, it will depend on what kind of line system you're going over. In the kind of line systems that 400ZR targets, you might go a few hundred kilometers. If you go to a regional or long-haul architecture where you're using Raman, you might go hundreds to even 1,000 kilometers or beyond. And you have the ability now, because you're also supporting lower data rates at 300 or 200. If you can't achieve a certain reach at 400 gig, you now have the ability to go even further reaches with the lower data rates. But also, I think the other feature that's important in terms of where it will be used is the multiplexing feature that allows you to kind of work with backward compatible 100 gig. If you're going from a, infrastructure on one side has 100 gig going to 400 gig on the other side, it gives you some flexibility to address different types of architectures there.
Okay, and then Rayhan.
Yeah, I would completely agree with Tom there. Obviously we have to take into consideration the optical fiber characteristics, and how the line system will compensate for things like dispersion. And if you are distance or reach limited, the flexibility of OpenZR Plus or ZR Plus will be that you can choose the modulation that can allow you to enable and achieve the extra distance, whether it's 300 gig, 200 gig, or 100 gig, and then you have the flexibility of the clients as well. So really, anything beyond the 120 kilometers that 400ZR can reach, ZR Plus can be used.
Okay, great. Well, I think in the interest of time, I'm going to skip over the next question. I think people have already referred to that a little bit. And go to the last question for Tom. Does ZR Plus need to work beyond 400G, or is that a different solution?
Sorry, took a minute to get off mute. So certainly there will be standards beyond 400 gig. I think several standards bodies are already starting those conversations to figure out what is next. I don't know if that necessarily falls in the category of ZR Plus. I think one of the challenges we've had as ZR Plus has been a catch-all term for a lot of different things. I think what we've done with OpenZR Plus is to try to have a more specific definition. There will be next generation standards at higher data rates. I don't know if that is ZR Plus or maybe that's a new OIF project.
Okay, great. Thanks for that. And I think now that brings us to the end of the discussion. And what we'd like to do now is go to your questions. We've had some questions come in already, but keep sending those in, and we'll try to get to as many as we can in the time that's left. So go to this first one for Mark. The question is, optical line system. Have you changed that? I think there was some comments on that on your slide.
Sure, yeah. So in principle, you could reuse the existing line systems with the 400ZR. Even though the line systems are optimized for PAM4, the 400ZR spectrum still fits through the MUX-DMUX pathband, and the amplifiers are sufficient in providing gain and everything to transport the ZR signal. But there are some optimizations in channel spacing and things like that that can be had by changing out at least the MUX-DMUX, and further optimizations by designing or introducing coherent optimized amplifiers that don't have mid-stage access and DCMs and things like that. So while in principle, yes, you could reuse the same line system, it's more optimal to upgrade that as well. But you can still retain the common line system infrastructure like the shelves and management communications and things like that, and just optimize the line cards that go in it.
Okay, great. I'm going to stay with you for this next question. I think it's fairly brief. So why was the 100G DWDM not standardized? That would be really useful for operators that are smaller than Microsoft.
Yeah, and that's a great question. I think the main reason was because at the time, we had to prove the existence of a DCI application space, and also the timelines we were trying to operate under to get a product developed to be able to support our regional designs weren't sufficient to go through a traditional standards organization. So we had to kind of fast track that one, and that's why we identified an industry partner. And once that was done and we started deploying these at scale, others saw that, oh, this is actually a viable product space, solution space that might be better addressed in some type of standards project. That's when we were able to do it for 400ZR.
Okay, this next question, I'll perhaps start with Rehan and then go to Tom. So will traditional embedded transponders coexist and compete with 400ZR pluggables?
All indications to us is that traditional transponders and OpenZR Plus based pluggables will coexist in the marketplace. There are some challenges to be solved there, as Tom had mentioned, in terms of leveling the output power from these optics, whether they're traditional transponders or pluggables. And there may be some instances where there is a competition between these technologies, especially in the short reach links. But we certainly expect these to be deployed in a hybrid configuration where service providers and data center operators are looking to leverage both technologies.
Okay, and Tom, any thoughts on that?
Yeah, I would say both will continue to exist. I think, generally speaking, I think most edge and metro type applications will shift more toward the pluggable and the ZR type infrastructure, and then I think embedded will focus more on long haul and submarine type applications. Okay,
great. I've got another question for you, actually, Tom. So, what are the advantages of Open ROADM and Open ZR+?
So certainly, I think it comes down to performance and functionality, and Open ROADM has even more of that because it's designed for OTN networks, so it's got a lot more flexibility on client interfaces. It's just designed for a different type of application, carrier applications. OpenZR Plus gives some of that additional functionality, so it allows a broader use case, and it allows higher performance. And so that's targeting a combination of maybe DCI applications who might not fit exactly into the 400ZR application mode, but also carriers who want to, you see things like Cord, where carriers are looking to redesign their networks to operate more like a data center. And I think OpenZR Plus plays very well into those types of models.
Okay, and actually there's a follow-on question to that, which is what can you say about the number of vendors participating in the OpenZR Plus MSA?
So there's 7 vendors that are participating. I'm not going to try to rattle them off right now because I'll probably forget somebody, and I don't want to do that. But there's 7 vendors that are currently participating. There was a press release that went out last week announcing that.
Okay, there's a very specific question. I don't know who's the best person to answer this. Can you use ZR Plus on DSF fiber? Anyone able to answer that one?
You can. It changes the engineering rules, but you can use it on. Yes.
Okay. So the next question is, if you're deploying the solutions ZR and ZR Plus that we've been talking about, do you need to re-engineer the network? Any thoughts? I guess Rehan, maybe?
Yeah, I can add some thoughts there. In terms of re-engineering the network, I think they're maybe not completely, but there are some nuances associated with the low output power coming out of the pluggable optics, the ZR and OpenZR Plus. And so, bringing those levels up to a level that is common with the traditional transponders, which are traditionally higher output powers, 0+ dBm and more, that challenge has to be solved. Of course, there's several solutions that are going to be available in the marketplace, larger form factors, which may have embedded EDFAs in them, or amplifier channel banks that can be added to a particular line system.
Okay, anybody else have any thoughts on that? Okay, so before we got time for just this one last question, which I've lost. Hang on a second. So the question was, oh yes, I know what the question was. I can't see it at the moment, but I can remember what it was. So the question is 400ZR, I guess ZR Plus, currently it's a point-to-point solution. Can you see any value or options in going to a point to multi-point type solution using that kind of form factor and approach? I guess we can start with Mark.
Yeah, I mean, for us, we don't have a use case. All of ours are strictly point-to-point links between two routers. But I've seen other use cases outlined where, especially as you get toward the last mile part of the network, point to multi-point can make some sense. But I'm probably not the best to speak to that.
Tom, do you want to address that?
Yeah, it's probably a topic that takes more than a minute to respond to, but I can't speak to it's not obvious to me how to adapt this to make it a cost-effective point to multi-point. I know there's some activity there that I'm interested to see how it plays out, but I have not. It's not something that we're actively pursuing.
Does anybody else want to come in on that?
I can add a few thoughts on that. Beyond point-to-point, we are seeing applications that will address not point-to-multi-point type applications, but rather ring configurations where these optics or the signals out of these optics are going across multiple ROADM sites within the metro. So we see applications like that. And then I think I saw a question about, on technologies that could be put on top of ring-based applications, things like MSTP or Ethernet ring protection. So certainly the physical layer can be adopted by OpenZR Plus technologies, and you can overlay any type of MPLS technology or layer 2 Ethernet technology on top of that. So ring-based architectures can also be supported.
Okay, great. Carl, did you want to come in or?
Nope, I'm good.
Okay,
Thank you.
all right. Right, well, thanks very much. I'm afraid we have run out of time. So thank you for attending this session, the Coherent 400 gigabit per second revolution. And that's brought to you by LightReading, Fujitsu, and Acacia. Please do stay on for the next session, which is open and disaggregated optical networks, reality test. And that will start in approximately 15 minutes. So thanks very much.
Testing, 1, 2, 3.
Testing 1, 2, 3.
Testing 1, 2, 3. Testing.
Testing 1, 2, 3. Testing 1, 2, 3. Testing 1, 2, 3. Testing 1, 2, 3.
Hello, everyone, and thank you for attending Day 2, Session 2 of the Optical Networking Digital Symposium. Thank you to our Platinum sponsors, Fujitsu and Cisco, and our Gold sponsors, Acacia and ADVA. I have a few reminders for the audience. On the left-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type the question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget, as well as other resources made available for download from our sponsors. Towards the end of today's presentation, we'll ask for your feedback. A survey will pop open, and it will only take a minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available one day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Heavy Reading's Principal Analyst, Sterling Perrin. Sterling?
Hi, thank you. Thanks, everyone. Hi, welcome back. For those who joined the morning session on 400 gig. I certainly enjoyed it. Hopefully everyone did too, and haven't seen who's on the audience, but maybe a lot of repeat from the Tuesday program as well. So we are moving into the second session of Day 2, and this one is focused on disaggregation and open networks. And here's a brief agenda for the next hour and 15 minutes. We'll kick it off with Telefonica. Victor Lopez, who will present on behalf of Telefonica on their views on open and disaggregation. Victor is also an important member in the TIP organization, and so at certain points he'll also speak a bit on behalf of TIP as well, but his presentation here is the Telefonica viewpoint. Then we'll be followed by our Platinum sponsor, Ron Johnson from Cisco, who will give Cisco's views briefly in about a 10-minute presentation. And then Victor and Ron will join us for the panel discussion, similar format to what you saw in the earlier session. And they will be joined by Stefan Rettenberger, who's Senior Vice President of Marketing and Investor Relations with ADVA. So we'll go through a number of topics there. And then we have about 10 minutes at the end, hopefully, for Q&A. And with that, let me get right into it and bring up, if I can get the slides right, bring up Victor from Telefonica to talk about open networking and the move to optical white box. So Victor, welcome, and looking forward to your presentation.
Hi, Sterling. Hi, everybody. Thank you, first of all, for give me the opportunity to speak here. It's a pleasure to spend this time with you. And as Sterling mentioned, the idea of today's session is to give you the view that we have from Telefonica side, how we are moving towards open networking, and how we think that the optical white boxes are becoming a reality. And so I will present some of the activities that we are doing within the Telecom Infra project, as Sterling mentioned in the introduction. So the first thing I was willing to do, it was to present to everybody which are the different architectural alternatives that we have in optical networking, and why we are finishing in this white box approach. But I was willing to start with the initial concepts of disaggregation in optical networks. So most of the traditional deployments that we have in optical networks is a design that is what we call fully aggregated design. So a fully disaggregated design is a deployment of an optical network where the entire transport network belongs to the same supplier, to the same manufacturer, and we are deploying in the field the solution from the very same vendor using their transponders, their terminals, amplifiers, ROADM, and any other device that we are deploying in our production environments. In terms of the management of this system, it is based on an end-to-end approach. Typically, we have an API from the network management system, and this API help us to manage and to provision services in this end-to-end fashion. Based on the evolution on optical networks, two big proposals are coming into the disaggregated environment. The first one is the partially disaggregated architecture, where this approach allows us to deploy the transponder from a third party. It doesn't have to be the very same vendor than in the open line system, and we can select the technology that is more mature or is more adapted for our needs for this service. The open line system is basically composed by the terminals, the amplifiers, the ROADMs, like in the upper part of the figure in the aggregated one, but it is managed with an API as an end-to-end system, just the line system itself. And the third approach, it will be a fully disaggregated approach where every device could be purchased, could be deployed, and could be programmed with its specific API, managing the device one by one. This requires to have interoperability not just from the transponder and the open line system, but also between all the elements that we have in the network. So if we replace one ROADM by the solution of a different vendor with another ROADM, the two boxes must be compatible, and everybody in the chain, everybody in the deployment should have the capabilities to talk with this device. And this will be the fully disaggregated approach. In terms of thinking of, in terms of a practical approach, which is the solution that we need as an operator, on the left part of this slide, we have the fully disaggregated view, where it will be basically like buying by ourselves the pieces of the Lego and building our own solution internally in Telefonica, in an operator, or with a system integrator. But it will be more a work of cherry picking, taking all the pieces of this solution and deploy them in production. On the other hand, if we have the aggregated approach, what we are doing is to buy the whole solution. And in the middle, we have the partially disaggregated approach that will give us the opportunity to select which are the components that are more interesting. If we think about all the ecosystem of partners that is involved in this big optical community, well, we could go to buy directly the components by ourselves. We could buy just the hardware systems in some scenarios. The management is another aspect that it will be critical to do this end-to-end integration if we are going for the fully disaggregated or the aggregated one. And also the system, the integration and the support, it will be a key point in the deployment of disaggregated solutions, because it's a new role or a new way to manage the network that is totally different of how we are doing today in our production environment. Why I put SDN as one key point on this evolution for disaggregated scenarios, mainly because we foresee that the SDN is the glue that help us to program this disaggregated environment in terms of hardware components for our management or for our integration in our systems. The SDN solution help us or enable us to deploy partially disaggregated solutions in a first stage, and later it will help us to deploy a fully disaggregated one. So in order to follow this path to deploy a partially disaggregated architecture, we can't forget that the first milestone is to have an open line system. There are some solutions from some vendors that doesn't allow to monitor or to manage external wavelengths that doesn't belong to their solution. So if you put the transponder from a third party, you cannot see any of the optical parameters of the signal, and you don't even have a BOA or in the WS you can control the attenuation of the signal in order to manage this external wavelength. So in this sense, the capabilities of the OpenLine system, it will be the first milestone in order to enable this partially disaggregated approach. The second point is have this API for the aggregated solution in production. So having an API like the Transport API that will help you to deploy services in an end-to-end fashion. And finally, have an interface to program the transponders using a southbound interface model like OpenConfig or OpenRodan. Any of them could be an alternative. What we've seen in our journey to deploy this partially disaggregated solution is that not all the pieces were supported. We have been working the last 3 years on this, and we have seen that it has been an improvement in the support of the industry. However, there is still some room for improvement, mainly with the alarms and the performance monitoring. And in terms of, I mentioned this in the previous slide, in terms of integration, support, maintenance, we need to collaborate with new partners in order to give us the capabilities to be agile and to make a reality the deployment of these disaggregated solutions. In terms of disaggregation, or how can we move from the left figure that we have in this slide, that is basically an aggregated system, to the right part that is a partially disaggregated system, there are two key points in this transition. So I'm assuming that we already have in production a northbound interface that enables you to program the network end-to-end. This is something that we've been working for a while with the Transport API, and we have it in production. And thanks to this interface, the only change or the two changes that we have to do is the interoperability of the data plane. As I mentioned before, how you can manage external wavelengths in this OpenLine system. And the second part is the configuration of the transponders using OpenConfig as one of the SDN enablers that will help us to configure any transponder using the same language. However, if you think about the concept of disaggregation in IP networks, is slightly different than the concept that I've presented so far. So when you talk in a router about disaggregation, it's not exactly the same idea than taking different pieces of the network from different providers. But the idea is that we are moving from a vertical solution to a software and hardware solution, which is the journey that we have had in IP networks. Well, in this journey, basically we used to buy a vertical solution from the very same manufacturer, what we call in this slide conventional network platform, where we were acquiring the software, the hardware, and even the ASIC of the router with the capabilities that was given by a given router provider. Thanks to the advent of merchant silicon solutions, the industry is moving their proprietary ASIC designs to a merchant silicon solution that allows us to deploy what we call proprietary white boxes. However, the operator doesn't have the capability or the freedom to take the software that is more efficient for, let's say, or have the required features for this scenario, because we are buying, anyway, we are still buying a vertical solution with the software and the hardware. So the concept of white box that I was mentioning at the beginning of this presentation, of open white boxes, comes with the idea that we have this software and hardware solution that will help you to deploy any software in any white box or that you are acquiring. The open software doesn't have to be open source, it could be proprietary, but at least give you the freedom to deploy it in any white box that you have in your production. In terms of, let's say, making a comparison, which is the concept of disaggregation in the IP network and in the optical networks, in the IP layer is more the component integration effort that we used to do with the PCs, and in the past we used to have a Mac with their own processor. It was different than the Intel solution. And in the optical layer, the concept that I mentioned to you before, it is more, if you want to make a comparison, it would be similar to a railway, where the open line system is the railway, and the trains are the different transponders that you want to make them to interoperate. In this white box ecosystem, it appears two roles that I wanted to highlight on this slide, that is basically the system integration and the system maintenance. So nowadays, when we buy a router or a transponder, we assume that the software and the hardware components are already integrated and they have been tested, and we have someone to blame. That sometimes this is the problem, or one of the values of having a single point of contact in case there is any problem. And also you have a partner or even the same supplier that is giving to you the system maintenance. In a scenario of white boxes, it is still open, which will be the best role for, or the best, let's say, ecosystem for this approach. And this is why later I think we will discuss more in the panel, but at least I was willing to integrate, to highlight this point, because these companies to give us the maintenance and the integration are key in order to make the white box ecosystem a reality. For optical networks, within the telecom infra project, we have been working in different transponders like Voyager, Cassini, Galileo, and Phoenix. And today I will focus on the Phoenix solution, where we are not just, let's say, decoupling the transponder like in the partially disaggregated model, but also it is a white box in the sense that we are designing the box with the software and with the hardware from two different vendors that we should be capable to deploy any network operating system in any white box. For those that are not familiar with the telecom infra project, I was willing to spend a few minutes or some time just to tell you that it's an open community where we are accelerating the way that the telecom operators are deploying our networks. So the idea is to build together solutions with an open networking mindset, test and deploy solutions. More than let's say, theoretical work or a theoretical activity, our idea is to be quite pragmatic and take them to production as soon as possible, as we have done with some work like the DCSG that now we have in production, for instance, in Telefonica. The group that I'm co-chairing is the Open Optical and Packet Transport. I'm not going to enter to explain you all the groups that are covering, that are part of the subgroup, but basically we are covering all the transport area, not just with the packet layer and the control plane part, but also the optical transponder designs, like this Phoenix project that I was willing to highlight today. So what is Phoenix? The goal of the Phoenix design is to build the first white box with 400 gig capabilities in an open specification. It is driven by 5 operators, Vodafone, Telia, NTT, Deutsche Telekom, and Telefonica. And what we are providing is an open technical specification. We are working with the partners to design device prototypes, and we will do lab and field trials in order to have a product generally available as soon as possible. In terms of the calendar that we have for these different steps, basically we launched the RFI in mid-April. we are still analyzing the RFI results, and we expect to have a conclusion of these results during June. And based on the answer of the partners, we will start doing the lab and the field trials, but we believe that we will be able to start this activity in Q4. So next year, we will be able to have general available products in this Phoenix design. I forgot to mention that even though we will work with 400 gig line ports, we are also willing to have different sub-slots with 100 gig and 200 gig capabilities, because there is still a lot of need for the metropolitan deployments to have a lower rate transponders for our services. And from my side, I was willing to conclude this presentation highlighting some points that where we are and why we are working on this disaggregation activity. Telefonica is deploying in our partially disaggregated program the partially disaggregated architecture I mentioned in the very first slide. We are working with an SDN solution that enable us to program the transponders with standard interfaces. We've selected OpenConfig because it's the one that we got feedback from our partners that it was more mature for their transponder solutions. And now we are working in this RFI to understand if the white box ecosystem will give us also an extra added value thanks to this decoupling of the hardware and the operating system. We are doing this work not just by ourselves. Even though we started internally a project, we are doing a lot of activities within the Telecom Infra project. And thanks to all the great team and partners that are working in the Open and Optical Packet Transport group, we think we are being quite agile in order to make these solutions a reality. And one of the open issues that we have right now is which will be this maintenance and integration model and how this can work on the field, because it will be to go a step further than in the partially disaggregated approach, where at least the vendor of the transponder is the owner of the transponder and the other partner is the owner of the line system. And finally, let me stress that we are working in this Phoenix project in order to have the first solution for a white box with 400 gig capabilities. And we see that this is an opportunity for telcos to assess if the white boxes is going to give us some technical, operational, or even economical advantages in order to deploy this white box architecture. And from my side, that's all so far, Sterling. So I'll give you the token. Thank you for the attention to everybody.
Thank you, Victor. Great job, and sets us up well for the discussion to come in a bit. Before we head there, and also quite a few questions have already come in, so don't go too far, Victor. Let's bring up our next presentation. Ron Johnson, Senior Director, Product Management and Architecture with Cisco, will talk us through Cisco's view on some of these trends. So, Ron?
Yeah, thank you, Sterling. I'll start by just giving you kind of our perspective of how disaggregation has evolved and how we've supported disaggregation over the past few years. Starting with in 2013, everybody was looking essentially for a completely integrated solution. Those solutions tend to be closed. In 2015, we had a lot of interest in separating the transponder from the line system, and having the line system then become open so that you can use any vendor's transponder bookended on a wavelength on any wavelength in the system. And that became a pretty typical way of deploying. That kind of opened up an opportunity to optimize the transponder only. So it was no longer a shelf that housed all the line system and the transponders in a universal way. It allowed for the transponder to be optimized into a small form factor footprint. And that could be a transponder or muxponder. and that would go over the same line system that was shipped in 2015. Since then, we've seen a lot of innovation on the transponder side to go to multi-reach, right? Having transponders that go anywhere from DCI short applications all the way through subsea applications. And we've also seen an opportunity for specific use cases to optimize the line system. So again, in a small form factor footprint, optimize the line system, for instance, for DCI or for long haul or for SLTE. And finally, where we see things going in the near term is that not only will we have these small form factor clients, but also in a much more meaningful way, based on the last session that was done on 400 gig, a pluggable design where we have multi-vendor interoperability for reaches up to 120 kilometers, and then multi-vendor interoperability beyond 120 kilometers with OpenZR+. And that also, we'll also see more investment in the line system, where in that small form factor, we'll be able to support even more applications like mesh, point-to-point, metro, long haul, ultra long haul, and even the SLTE subsea applications. I've been updating this slide over time, as we talk about disaggregation, and it's very interesting to look at to call this the evolution of disaggregation. Certainly, a lot of our customers who enjoy a fully integrated solution think of the evolution more like this, where it's de-evolved and they have to take pieces and put them together to integrate. And so what I wanted to acknowledge here is that there's certainly value, I think, for many service providers to leverage a disaggregated solution, but also acknowledge that there's still value in a fully integrated solution. And I think one thing that we should acknowledge here is that this has created some fragmentation in the market. It's complicated in many ways, the development of these systems, because the interfaces could come at many different levels, and that's exactly what I want to show you in the next slide. In some cases, we have providers that want to consume components, right? Optical engines, DSPs, ASICs. In other cases, we see modules being the right way to integrate into a provider's either white box or their own developed solution. That could mean that DSPs and optics are integrated together into a module, or they come as a DCO pluggable. Others want to consume at a box level, right? And in that box level, they could buy the hardware only, they could buy software only, they could buy hardware and software. And in this case, similar to OpenROADM, for instance, that has to interop with other boxes in the network that are doing similar functions. And then finally, we still have a lot of customers at the solution level where they look for a multi-layer solution, integrated hardware and software, automation, optimization, network design, and so the approach and the level of integration is different for each of these. The support model is different for each of these, right? I mean, selling a DSP is different than selling a network, for instance. And not everybody's ready or wants to take on this integration effort, but for those who do, I think there's some interesting opportunities to leverage the industry in a different way and get some outcomes that they desire. And for others, it's a complete nightmare to try to transform their operations into building and doing the integration themselves. So, as far as considerations and recommendations, my view is just to go in eyes wide open and consider all the costs. Where we see white box models failing, for instance, is when you get a team that's really excited about building the first release of a product, the first defining it, bringing all the pieces together, making it work, getting it up, getting the software working. That's an exciting time of the lifecycle management of a solution. When things change, like components go end of life, or things force a redesign in the platform, oftentimes that can be either something you want to outsource or something that can be quite painful in terms of keeping a team around and sustaining that development. But I think the integration costs, the lifecycle management, time to market, which could be a motivation for disaggregation. It could also be a detriment coming from disaggregation. Bundled versus unbundled, meaning that oftentimes in this DWDM market, there's a commercial approach to a consumption-based model with pay-as-you-grow, where the ROADM is subsidized and you pay an extra tax on the transponders, and you have to buy those transponders from a particular vendor. We either see that, or we see situations where there's a right-to-use fee or a line card that's required to run alien wavelengths over a system. So just be aware of all of those issues and challenges, and make sure that as you build your business case around considering disaggregation, that you keep these things in mind. I think what it does allow you to do is optimize for your needs, so you can focus on a very specific topology and not buy something that's overkill for your application. You can also focus on your specific traffic patterns. And I think this becomes really important as the network starts to fragment, or the applications start to fragment. And we see many customers with many endpoints, many A to Z pairs with little, light traffic on those A to Z pairs, and other customers with very few A to Z pairs with tons of traffic on those in those links. Meaning that if 100 gig gets deployed running 10 gigabit of capacity, going to 400 gig is not going to be very helpful, right? In fact, it's just going to consume more spectrum to do so. Maybe even cost more, right? It's lower cost per bit, but if you're only running 10 gig over, it doesn't matter. So it's important to consider these things as you think through how to build your network. But also there's a consideration around best in class and good enough. A lot of times the motivation is not to get the best thing in every part of the network, not gold plate everything, but figure out what's good enough so that you can open up an ecosystem that provides for an opportunity for multiple vendors to supply into that, and therefore give you more commercial leverage to create an opportunity to get a lower cost, on those components. And I think the other thing I would recommend is that you just look at what's going on in the industry and take advantage of what's going on. There's open ROADM developing models, there's open config developing models, there's TIP, there's OIF, there's all kinds of opportunities, or ONF, sorry, there's all kinds of opportunities to leverage what's out there. And I think there's enough overlap between applications now that there's probably less likelihood that we'll start new standards, and start to leverage the work that's already been done in some of these forums. The other thing is volumes. You may see a situation where the volume could be really, really high in an application that doesn't apply to your company, but taking advantage of where that solution is driving capacity could lend to a much lower cost, could lend to attract a lot of investment from the component suppliers into that space. And so watching that and taking advantage of that is important. And then architecture and scale are interesting. I mentioned it, this A to Z challenge. You may look at higher bit rate solutions and consider different architectures in your network to take advantage of those because of the way that your traffic pattern is, for instance. And with that, Sterling, that's what I wanted to share in my 10 minutes.
Thanks both. So now we will move into the panel portion. So if you tuned in earlier, it'll be a similar format. We have a number of panelists, including our two speakers already. We've got a set of topics already on hand that we'll go through. And then we'll take, I think, about 10 minutes for your questions at the end. Let me just introduce our panelists here, or reintroduce Ron Johnson, of course, who just spoke, Victor Lopez, who spoke first, representing Telefonica, and then our new panelist, or new speaker, who will be a panelist, is Stefan Rettenberger. He is Senior Vice President Marketing and investor relations with ADVA Optical. So everybody should be on now. Let me just give an abbreviated version of my commentary here, and then we'll get into it, because I want to make sure we have time for the discussion portion. I'll just talk through this one slide, which is, and actually Victor and Ron set this up pretty nicely already anyway. But we're focused on optical networks here, so I really wanted to get at how does the disaggregation trend apply specifically to optical networks. And the key point that we've seen is in optics, we're very much seeing a migration from proprietary monolithic systems of the past to merchant technologies, and merchant technologies and systems applied in ways that are increasingly open. And so really that, we look at optics and DWDM systems, really where we saw that start, what I think kicked it off was Acacia and their merchant DSP and modules they created, beginning with 100G systems. Cisco benefited from that and is in the process of actually acquiring Acacia, as I think most people know. ADVA benefited from that trend as well. So, that was really the first launching pad for moving away from these monolithically built proprietary systems to really bringing in merchant technologies and moving the market quite a bit. Merchant also applied to, so if we talk about packet optical, Broadcom has been really the key enabler there for switching fabrics, has transformed the routing industry and how that's being built and sold. And also, as we talk about packet optical, comes into play there. Another key enabler or move towards from proprietary and closed to increasingly open and merchant is open APIs. So this is a software element to it, but the ability to use SDN technology to work towards what I think many would call vertical disaggregation as opposed to horizontal. So the ability to separate the control plane from separate the hardware from the software operating system increasingly. With open APIs and data models. And then the last point I'll make before we kick off the first question is just to be very clear on white box. White box and disaggregation are not synonymous. They are white box is a subset of the disaggregation trend. And so, Victor's talked a lot about the white box implementation of disaggregation. There is a lot of disaggregation with white box. There is not white box without disaggregation, but moving to white box has its own benefits and challenges, and we'll get into that. But I just want to make the point very clear that if you are not a proponent of white box, it does not mean that disaggregation, won't apply to your network in any way. They are different. With that, let me. I may come back to these slides as we talk through some of the discussion on standards. But Stefan. Hi, welcome. I'll let you I'll let you take the first topic for us since you have not had the spotlight yet. But defining disaggregation, we've sort of had Telefonica and Cisco views on that. So I'll let you kick off with how would you define disaggregation in optical networks, different degrees of disaggregation, and see if we have any discussion points on that.
Hi, Sterling, and hello, everybody, and thank you for having me on this panel. I think both presenters actually described the different flavors of disaggregation really well. So you can either disaggregate horizontally, and I think in the optical domain, this is really where a lot of the action has happened so far, separating the terminal from the line system, as Ron had said originally. So we try to work with alien wavelengths. Then we may work with plugs sitting in a data center switch going over an open line system. So there has been a good amount of experience and real life deployment in that space where separating the terminal or the transmit receive optics from the line systems have proven to be really valuable. Not in every system, but there's more and more applications where this is something to be considered. On the slide that you're showing now, this will be the bottom part. So the horizontal disaggregation separating the terminal from the line system. The middle of that drawing is pretty much the state of the industry today. Disaggregating further down into individual network elements, so it would pretty much mean splitting the line system apart a little bit further. I have a strong opinion about that and think it is only in very few cases, if at all, meaningful, but I think this is what we're going to discuss in the next half hour or so, and there's pros and cons for doing that. What sits on top is the other form of disaggregation that involves the white box models. So ideally separating the software from the hardware, as you said. So you have a universal layer at the bottom and an operating system on top that makes the universal hardware do something and turns it into a network element. Before that, we've already seen what I would call a delayering. So there were times in our industry where people really favored God boxes, where all the functionality across multiple layers sits in one network element. I think more deployments actually have happened in the space where switching and routing were separated from the optical transport layer. And again, now the question is there any value in optical transport when you separate the operating system and put that on top of a standardized white box type of hardware? I would argue in other areas of the networking space, and I think also Victor and Telefonica have played a lot in that field, is meaningful with, for example, disaggregated cell-side gateways. So here you have a network element where you have very high volumes in the network, and then you try to make sure your supply chain is open, the network isn't overly complex, the operating system turns that bare metal switch into a cell-side gateway. And you could even take it further and virtualize things. In that case, the universal CPE comes to mind, a bare metal server with an operating system that can then be turned into an SD-WAN device, a firewall, a carrier Ethernet type demarcation device. So I think there's places in the network where disaggregating in the vertical level, separating the software from the hardware, the what from the where, makes sense. In the optical transport space, I think more the horizontal disaggregation, things like separating the terminal from the line system that we see at the bottom of the slide, are the commercially more relevant applications.
All right, good points. Let me, I'll go to the next topic. Unless, Ron, did you have anything to disagree with on Stefan's comments? If not, I'll go to the next topic.
Sorry, just getting ready. No, I agree. I mean, I think we all defined it a little bit differently, but it's pretty close to the same. That there's vertical and horizontal disaggregation, and that I see a lot of the questions on the chat regarding what's the value of doing that, or why would you want to do that as a provider. I think that would be good to discuss.
Yeah, why don't we do that right? And I think this next topic will bring it up to a degree. Why don't we start with this one and then weave it into what is the value? Because, you know, so lessons learned from early disaggregation deployments, what worked, what is not, and then I think as a subset of that will be what's the value of doing it. The poster child for that has been the TIP Voyager project, which was TIP's original foray into white box packet optical systems. I'll start with you, Victor, since you are kind of putting on your TIP hat, and I think Telefonica did some work with Voyager as well. Can you give some of your lessons learned from the early deployments on TIP and with Voyager, and what was worked? And I mean, this project was shelved as far as I understand, so maybe kind of what was the death knell for it?
Yes, well, regarding the Voyager project, Telefonica was not highly involved because we were not yet part of the OPT working group. However, which are the lessons learned and which are the things that we are changing in the Phoenix or in the Cassini deployments that we have nowadays? So what we are trying to do is get a specification that is wide across the industry. So the original design for Voyager was coming from basically a single operator at this point, and it was not matching all the needs or the requirements, or a gap in the industry that the commercial solutions were not already giving to the market itself. So at least from our side, with Phoenix, we've tried to get 5 important operators, and anybody else is welcome to be part of the project. And this will be the first point that has changed. The second point, it will be this reality with the ecosystem and the difficulties that we have in order to open up an environment that has been working for so many years in a closed manner. So it takes a lot of time. I think it has helped a lot to evangelize and to provide to change the mindset of the people around open or disaggregated solutions. And for instance, Cassini, that was the second design that it was done in TIP, it's already in production, for instance, in Chile. So in this sense, I think that we are improving the ecosystem. The partners and the needs are coming more from the operators, and I think that we are being more successful than with the initial design that we did.
Okay, Stefan, I know. Yeah, sorry, I forgot Telefonica's involvement. I know ADVA was involved as an early champion of Voyager specifically. Maybe you can address some of the shortcomings there, and also get into the question of, did the project get dropped because there is no value into this type of fully disaggregated white box type of system? Is that the lesson learned?
I think there were a couple of things with Voyager that I would say in hindsight went wrong. I mean, we're a highly innovative industry, right? We're a bunch of engineers and physicists, and whatever is technologically possible, we like to play with it. Ultimately, if it doesn't prove in commercially, then things don't get deployed. And if the operational teams of our customers, this is not what we need, then it's not going to take off. I think taking it back a step, even when you look, white box solutions have been highly successful, then it is always in environments where you have a number of network elements, maybe not overly complex, and what you want to buy in the market is not really there. So data center switching, I think, was a space where some of the vertically integrated vendors had good solutions. After the value creation, the software made the box overly expensive. Maybe it even did too much. And the hyperscale guys said it's much more economical for us to buy a bare metal switch, the merchant silicon that you alluded to. And since they have strong software capabilities in-house, they programmed these devices themselves. And there you all of a sudden had a commercially successful white box approach. Voyager was pretty much designed as a transport terminal that integrated some packet functionality. Now, there's very few use cases where people absolutely have to have packet integrated with transponder. That's the first thing. And secondly, if you need a transponder only, there's 5 vendors at least out there that have the right hardware, that have the right software, at the right pluggable optics at a price point that is really compelling. You can get that from Cisco, you can get that from ADVA. There's 2 or 3 other vendors out there. So I think the space where Voyager would play commercially was very limited. And because of that, I think, we had about 10 customers that were actively trialing it, but it was mainly those playful customers, those that like to try things and build their own, and like the research and education guys, etc. But in a bigger volume consumption, Voyager just never really fit in.
Okay, great. Ron, I'll let you have the final word on this one. And why don't you maybe just primarily address that question you raised, which is the value of a fully disaggregated system to a service provider. Is there one, and what would be Cisco's view on that kind of more far end of disaggregation?
Yeah, I mean, I've heard of a lot of motivations. I think, one key word I think is control. That if a customer is looking to adopt new technology quickly, if they truly implement a good set of APIs that mean that they publish to their customers exactly how to fit into their network, and we as suppliers show up with that capability at whatever level they're looking to integrate with, that allows them to take on that integration function in a much easier way. I think that's one. Another is maybe they want best-in-class technology, and they don't want to, for instance, lock themselves into line system vendor and their transponders. They want the flexibility to take advantage of the constant leapfrog that's going on, in the transponder space around, getting faster and faster or higher performance for different applications. Another motivation, which I think is tied to the OIF ZR pluggable effort is commoditization, right? So I think there's many different motivations, all of which I think lead towards flexibility and cost in some way, but also provide new functionalities in the network. And the one thing I would add about Voyager that I think is interesting is there was a few things in my view that went wrong. One is it was a bit too off the shelf, right? You take components that already existed and put them into a box and make something out of it. We don't typically build products with off the shelf stuff, right? We build products with something that's innovative and new. And, so taking on the effort for something that generally you can get by combining two other devices together didn't provide a lot of value. And the ratio, I would say, between packet capability and DWDM capability was off. That there was, very small packet function, on top of a pretty robust DWDM function. It seemed like a bit of a mismatch.
Interesting. All right. Let's, in the interest of time, let's move through here. This is a big topic. Victor alluded to it, or actually tackled it directly a bit in his presentation. So there are challenges to moving to disaggregated optical network models, and white box as a subset of that. So maybe spend some time talking about what the industry is seeing as those challenges and what maybe some solutions are. Ron, maybe I'll keep you on to start this, and then we'll kind of move through the panelists. I suspect everybody would want to say something on this one.
Yeah, I think the challenge here is integration, in my view. That taking on the integration of either hardware or software is hard, and some I think have the DNA to make that a natural thing. They've had to do that for instance, in the data center, to bring together all of the different components of the data center already, and they've been able to leverage that to apply it to the WAN. Whereas others, they're building something that's just like what they got from the suppliers in the past, and I think that's really difficult to take advantage of. I would say though that this is getting easier, right? As more and more forums or MSAs publish their models and publish their capabilities to design the network and operate the network with common APIs. I think that's it's going to make this topic more and more popular, and more providers will be willing to take this effort on.
All right. Maybe Stefan, from your experience talking with customers through, just the course of your work, what is the primary? Is it typically the integration challenge that comes up? Are there other operational challenges, and does ADVA have answers?
So I think there's a couple of aspects that I'd like to actually follow up on. Ron said rightfully so, the terminal innovation speed is phenomenal. So in terms of new modulation schemes, higher baud rates, etc. And ideally, you want to keep yourself open to leveraging the innovation on the terminal side. But not every time a new generation becomes available, you want to rip out your line system. So ideally, having a line system that is somewhat tolerant to a new generation of optical front ends, there is some benefit there. Clearly, there's use cases like we had seen in the data center interconnect space, where some people want to use plugs that actually use some PAM4 direct detect optics, and then there's a different set of requirements for the line system. But the overall theme continues. There's a terminal transmit receive component, and then there's a line system that needs to make sure those wavelengths actually get to where they need to go. Separating the line system into further components, we have found this is of limited interest to them. On the contrary, since they all are interested in anything that was historically called an alien wavelength solution, they think the line system itself actually needs to be a highly integrated, almost monolithic system that takes care of gain control, if it's direct detect non-coherent optics, of dispersion compensation, of the modem wavelengths routing functionality, etc. So it seems almost that with separating the terminal, the line system itself needs to actually bake more end-to-end. And then as Victor said, SDN is the glue that puts everything together. So some of our customers want to talk directly to the terminal on a device level, but the line system typically is being controlled as a domain. It creates a very manageable setup. So terminals, fast innovation cycles on a device level, and have the line system as a resource pool controlled as a single domain that you don't separate further down to the device level.
Okay, and Victor, maybe give you the last word on this. I just put up a slide to show that in terms of operations challenges, you are not alone at Telefonica with having some concerns. Would you say that the primary issues are the white box model of disaggregation, or are there large challenges just across the board for optics disag?
No, before going to or reaching the level of disaggregation that the white boxes requires, even in the initial steps, the main problem that I see is the mentality of the organizations that we have. So in the operators, it is complex or difficult to change the way that we are operating our network, the way that we are planning our network. So this is a first barrier that we have internally by ourselves. The second point that I stressed in the presentation is the partners. It is difficult to find a brave partner like ADVA in order to jump in on a project like Voyager, try to work on it, learn, and they are doing the same in the DCSG, and propose an alternative model to the market. So it is becoming difficult to the big players that we have nowadays in our network to explain them or to justify them why it is important. So I think these are the two major points that we are facing in our deployments when we are planning these disaggregation projects.
All right. Let me go to, this was an interesting topic. In our call, Ron, I believe you were the one that raised this issue in sort of these exact words, which was an interesting, to me, interesting. Are standards helping or hindering progress in disaggregation in optical networks? I guess we like to think that standards help, but maybe not always. Do you want to give your thinking behind that topic, and we'll see if the other panelists have some comments as well?
Yeah, at a selfish level, I think the challenge for a system integrator or NEM is that we have to now engage customers at each of the levels that I described earlier and support them at each of those levels. And that oftentimes means that the software development is very different than it used to be. It used to be that we could support a couple of different interfaces at the northbound and be good with it. Now we've got many different forums driving many different models, which all have development requirements to at least translate from the model into our software, and that's it's not insurmountable. It's something that we've done, but it's something that does provide an extra amount of effort associated with getting the product that a certain customer wants with the interfaces that they want. And as I mentioned earlier, if the more we can leverage the models that have already been built in the industry and not reinvent the wheel, and I understand why the motivation of like Open ROADM, for instance, is very different than Open Config. And there was reasons because they were consuming at the box level that Open ROADM's models look the way they do. But so I respect that, and I'm not saying that that's a bad thing, but it just does change the development effort, and it makes the development effort more difficult.
Victor, I imagine you're a proponent of standards. Are you finding frustration in standards development, too many groups, too much competition, or you feel everything's pretty good?
Well, we've changed our mentality, I would say. We start with this problem of fighting the different initiatives, projects, and so on. And at some point, we realized that we have to choose. We can't wait to design everything everywhere and later do a theoretical analysis to select which is the best technology. And what we did, it was to select some standards or open source approaches like Transport API or OpenConfig that are standards, but at the same time, we work more in a DevOps approach with GitHub, where we are putting the additional changes to the public as fast as possible and start testing. Because if we wait till everything is defined theoretically, this transition to SDN, that is key, it will take us a lot of time. So we have seen that there is a complexity there, but at the same time, we think that having an industrial a group of people that are supporting the same technologies are fundamental if you want to make a reality this disaggregated environment where we need a glue to operate the network.
All right, Stefan, I'm going to let you take the last topic before we move to Q&A, but do you have any comments on standards and where ADVA would play, and any complaints for the industry on standards?
I think our industry, possibly more than any other, needs standards, I guess. Well, we're past times where ITU was sufficient. In general, I mean, we are tip. We like OF. I guess you're also asking here what groups are relevant. We're active in ONF, etc. But as you indicated, too many standards and expands the development effort and agile and bring products to market quickly. So having too many standards that you need to follow is sometimes counterproductive. The good news is that some of these groups seem to be converging. Some of the reason behind this may be that it's the same individuals that are active in multiple of those standards bodies. So I think right now it's going in a good direction, but sometimes I think less is more in that context.
Right. It seems to be the view, but it's tough to move forward in telecom without them. Let me go to our last question because I want to have about 10 minutes for Q&A. Stefan, I'll let you take this one. In fact, I think you also have a slide to go with it. But we talked this morning and even on Tuesday quite a bit about 400 gig revolution in optics, pluggables. Specifically as we think about this topic, disaggregation and white box, I'm curious what the panel thinks are the impacts of 400 gig pluggables on disaggregation and white box. To me, it seems like it would be a strong enabler, but wanted to get your views and thoughts.
Yeah, I mean, clearly, the advent of coherent plugs is changing the industry. I think the most obvious use case will be simple point-to-point networks. I guess these have always been the use cases where separating the terminal from the line system was easiest. The more complex the network topology is, the more difficult it is to first of all separate terminal from line system, but also then to use pluggable optics only. To what extent it will accelerate the use of white box remains to be seen. I think what really matters, again, is the total cost of ownership. And in the context of total cost of ownership, we always like to look also at the way how we utilize the available spectrum. So in greenfield, you can always from scratch, and I guess many greenfield deployments, certainly in the context of DCI, especially metro data center interconnect, and their high baud rates, tight channel spacing, etc., all that is fairly. We also, however, have had use cases called a flex grid brownfield, what you see in the middle here. These are longer reach networks that no longer just use the ITU grid, but have flex grid ROADM technology. And also here, I guess it's beneficial that the terminal can adjust its modulation scheme, etc. And then what's more interesting, I'm sure Telefonica has a lot of ITU fixed grid line system installations. I know some of the other telcos have as well. Here there's also ways with new coherent optics and modulation schemes to make better use of that available spectrum and filling it nicely. So we've done some interesting work with multiple telcos, data center operators, using our terminal over different line systems. But coming back to the question of the plug, yes, I think especially in the left-hand scenario, plugs will change that application space quite dramatically. It will take longer for those plugs to move into more complex network scenarios. And those plugs can sit in a white box environment, but they can also sit in a box that is being designed, architected, and controlled by a transport specialist.
Ron, maybe for you, as the last view here before we move to some questions, but this last bullet, I'm quite curious from Cisco's view, the impact of the 400 gig pluggables, just generally even on traditional telecom supplier operator relationships and how those will go forward. So, you know, aside from the hyperscalers, what do you see as the impact? I mean, Cisco could benefit quite a bit from IP over DWDM on the routing business, but did telecom customers want that?
It's a good question. I think Stefan hit it on it a little bit earlier. The operational boundaries, you know, between organizations certainly is a big deal there, right? It bridges boundaries that have been very stiff, you know, in the past, and I think there's clearly big advantages to having a line card and a router that you know, regardless of whether you're going meters or 1,000 kilometers, that you can trade. You just use a different optic and a different port to support that, and not even a different line card. But I think, you know, one of the things I would say about pluggables is the interesting thing that I think will be valuable to a service provider is that this is the first time that we really have a meaningful capability, meaning, you know, ZR reach, ZR plus reach type applications that are multi-vendor, right? Where you can have vendor A on one side of the circuit, vendor B on the other side of the circuit, and be completely interoperable, and that should drive to make these optics a commodity for those applications. Now, like what was said in the previous session on 400 gig pluggables, I mean, there'll be opportunities to differentiate, right? Have you know, extra capabilities, you know, in some of the different pluggable technologies, so that if you book into, you get more value. But if you size your network based on the ability to take advantage of the standards, then I think this is going to be a new way that'll exist in this space that'll allow service providers to get to a lower cost per bit.
All right, with that, let's in the interest of time, let's get into the Q&A. We've got a thank you to all the panelists for your thoughts, and thanks for the presentations. We do have quite a few questions in, so I don't want to leave these guys in the lurch. Yeah, let's see. You know, first question, Victor, this one's interesting. Based on your presentation, and we've talked about the different scenarios and architectures, partially disaggregated versus fully disaggregated. Stefan made an interesting comment that I guess horizontal disaggregation is more of interest in optics, or a better fit, but curious, partial versus full, which direction is Telefonica going ultimately, or is it going to be a mix?
We are working on partially disaggregated architecture only so far, and the reason is that we see that it is an evolutionary step. It will be the first one. And in terms of benefits, most of the innovation, the value added of the solution is basically on the transponders. And we think that we can have a more open ecosystem also for the commercial processes. And this is why we are focusing on a partially disaggregated model. We are not discarding the fully disaggregated one, but so far we don't see clear benefits to start this in a deployment process, because we haven't seen numbers that give us most of our investment is more in the transponder, so we don't see the value to start with the line system element.
Okay. Question for, well, I guess for the group. I mean, we've covered this to a degree, but the question did come in about the actual who will take on the systems integration role and maintenance. The operator. I mean, is that the consensus of the panel? Is that it's up to the operators to do it, and those that do will move this direction, and those that don't, maybe will do less disaggregation. Maybe start with Ron, and then I'll let Stefan comment.
I would say the early adopters for disaggregation certainly took on most of that effort themselves, but it does open up a different engagement model. I mean, you could have companies that live at any level of capability. I mean, some of that could be a white box manufacturer. You know, it could be an OS vendor, right? That's enabling disaggregation for a particular provider. It could be a software only vendor. I mean, it opens up, I think, a lot of new opportunities. I think it could create a challenge in making a decision for a provider to determine how to piece it all together. I think that's a new muscle that isn't that strong in many providers today. But I think it will create a new set of ecosystems for all the different pieces of the stack.
All right, Stefan, I'll let you comment on that from what you're seeing. Is that typically how it plays out? The operator takes on the role, or just isn't going to bother, or is there some other integrator to emerge?
I think you're hitting on a really important point here, and I think Ron brought it to the point. It create new opportunities, and it comes with a whole set of challenges. I mean, many of the tier one are scaling back their ability to install, to commission, and even to maintain their networks. So in that case, to go even more disaggregated and individual piece parts from different vendors. So there's either space for a new solution integrator, or the disaggregation should only go down to the partial level, like Victor said. So I think it's not easy for a big network. It's easy for a point-to-point data center interconnect solution, but for a larger scale network, I think the operational aspect and the system integration must not be underestimated.
All right. Let's see. I think we only get time for one question left. You know, and on this question, and actually, let me just push the survey out. So everybody, if you can take a moment before you close out to take our brief survey to give us some feedback, especially since this is a new format for us and a new type of event. So we'd like to know if it works. Hopefully it does. Where, you know, so disaggregation in optics and packet optical, you've got access, metro, long haul, maybe some other types of segmentation. Curious where you see ultimately the most impact in, you know, by segment, however you would clarify or care to define it. Stefan, maybe I'll let you start, and then I'll go to Ron, and then maybe let Victor have the last word. So packet optical, where does it fit best, disaggregation?
So again, in Alpha, we've never been big fans of packet optical integrating the packet function with an optical terminal. I think the majority of what we have been selling and deploying is more a pure play transport solution. But we've had many scenarios where we had our terminals going over somebody else's line system, or where we have taken wavelengths from switching and routing devices into our line system. Many of these deployments with alien wavelengths happened more in the metro space. I guess this is also where ADFA is the strongest. But we've also had recently success in wholesale networks that were going longer distances. So in the context of even offering spectrum as a service. So clearly the big consumer of wholesale bandwidth today are the data center operators. Instead of just consuming 100 gig or multiple 100 gigs, they're now more interested in even just getting a piece of the spectrum and then bring their own transponder or their own plugs to the offering. And I think that's an interesting emerging market, but metro, it's already here. alien wavelength support has been happening for quite some time. Long reach wholesale is an up and coming interesting opportunity. Access, I would say, remains to be seen, an interesting area to watch.
All right. And Ron, I think I'm going to have to give you the last word because we're at the end of time. But from Cisco's view, and I'll clarify it, optical or packet optical, where is the greatest opportunity in disaggregation for Cisco in the next several years?
I mean, I think just a quick comments on packet optical is that it's there's been a lot of integration between DWDM and packet in the past, and that was in my view very forced because it was going after a niche application, and there are many people I think that have taken advantage of those niche applications. I think the big change going forward is the scale and size of the routers has changed dramatically. The capability to achieve all of the openness of ZR and ZR Plus or OpenZR Plus is changing things dramatically. The cost points of those technologies, is really allowing for situations to throw bandwidth at problems or take advantage of different architectures because of those economics. And so I think that the one thing I would suggest is that people have an open mind about it and they look at all of their options and look at different architectures to solve the solution, because what worked last year and what has worked to date in marrying DWDM technologies and layer 3 technologies has changed significantly, and there's new opportunities I think to leverage that in a different way.
All right, excellent. And we are a little bit past time, so we're going to have to close out there. But I want to thank Cisco and ADVA for sponsoring, and thanks to all of our panelists here today. Thank you, Telefonica, for joining us. Thanks, Victor. And that will close it out. But hopefully everybody enjoyed the session. I certainly did. Thanks, and enjoy the rest of your day, everybody.
Thank you.
Thank you.